Hello there, Mr. Sutton here, bringing you the IM3 Honors 3-1 Part 2 Homework Solutions on Introduction to Imaginary Numbers.
To simplify this one, we need to first take this negative inside the radical outside as an I. So we've got I radical positive 64, and now we can just take the square root of 64 to get 8, so that then is going to be 8I. To simplify this radical, we have to take care of the negative by taking an I outside. So we have 3I radical positive 48 then. And then I have to simplify the 48. So the biggest perfect square that goes into that is actually 16. 16 times 3. So if we square root that 16, we can write 4 times 3I, which is really 12I radical 3. The first step to simplifying this radical is to take that negative out as an I. So we'll write 7I radical positive 27. And now we have to split up 27. Biggest perfect square that goes into that is 9. 9 times 3. So we have the square root of 9, which is 3. 3 times 7I is 21I. So then we have 21I radical 3. To simplify this power of I, we need to figure out where in the cycle of 4 we're falling with this exponent. So let's divide 64 by 4 and then just see what the remainder is. So 4 goes into 64 evenly, remainder of 0, which means that I to the 64th is equivalent to I to the 0. And I to the 0, like anything to the 0, is going to be just 1. To figure out I to the 25th, we need to divide the exponent by 4 and see what the remainder is to see where we are in the cycle of 4 that repeats. So 25 divided by 4, 4 goes into 24, so that's a remainder of 1 then, if we go into 25. And this means that I to the 25th is really equivalent to I to the first, I to that remainder, which means this is just I. To figure out this power of I, we need to figure out where in the cycle of 4 we are. So let's divide 70, the exponent, by 4. And if we do that, well, 4 goes into 68 evenly. So to go into 70, that would be a remainder of 2. This means that I to the 70th is really like I to the second. It'll give us the same value as that. And I squared, you're basically square rooting the square root of -1, so that just comes out to -1. To simplify this power of I, we have to figure out where we are in the cycle of 4. If I divide 37 by 4 to find the remainder, well, 4 goes into 36 evenly, so this would be a remainder of 1. And that means that I to the 37 is really the same as I to the 1, which means it's just I. To simplify I to the 47, I need to figure out where we are in the cycle of 4 with that 47. So 47 divided by 4 is going to give us a remainder of, well, let's see here, 4 goes into 44, so this would be a remainder of 3 left over then. And that means that I to the 47 is really the same as I to the third. And I to the third, as we know, is -I. On this one, we're trying to figure out I to the 92nd power. To do this, we're going to try to figure out where we are in that cycle of 4 that I goes in. So let's divide 92 by 4 and see what the remainder is. Now, 4 actually goes evenly into 92, so that's a remainder of 0, which means that I to the 92nd is really the same as I to the 0, which is 1. On this one, we're trying to simplify I to the 97th, so we need to figure out where we are in that cycle of 4 with 97. 97 divided by 4 is going to give us a remainder of 1, because 4 goes into 96 evenly. So now this is really the same as I to the first power, which is I. To figure out I to the 74th, we're going to divide 74 by 4 to figure out where we are in the cycle of 4. And in this, we're only concerned about the remainder. So now 4 goes into 72 evenly. That means 74 will give us a remainder of 2. And that means that I to the 74 is really the same as I to the second power, I squared. And I squared is just squaring the square root of -1, which just gives us -1. To figure out I to the 59th, we need to know where in the cycle of 4 we are. So let's divide 59 by 4 and see what the remainder is. So let's see, 4 goes into 56 evenly, so this would be a remainder of 3, which means I to the 59th is really just like I to the third in terms of the ultimate answer. And I to the third is going to be -I.